I'm going to introduce our two keynote speakers first, but I do want to take a moment and ask us if we would all join in just a moment of silence for President Bush, who was really a distinguished leader of our country, and I know we're all sad to see his passing, so if we could just take a moment of silence to remember him and his family. Okay, thank you. So, I was talking, I had the pleasure of being at a NIST event last week, I think it was, where it was the 30th anniversary of the Manufacturing Extension Partnership, which is a fantastic program that NIST operates to help SME manufacturers really modernize and become more technologically advanced throughout our nation. And I was sort of struck by the fact that the average age was quite high, including myself. And I knew people, met people there, saw people that I hadn't seen in 30 years, 20 years. And the point I'm making is, I think manufacturing, if you're old enough to remember it, really was a pretty powerful topic in Washington back in the late 80s and early 90s. A lot of people were talking about it, largely because of the Japanese challenge and to some extent the German challenge. And it wouldn't just talk about it. Congress took a series of very important actions to advance manufacturing policy, and I see Chuck Wessner, Joel Yuding. We all know about this. We've all Yudkin. We've all been involved in it. But I think that's coming back now, and I think there's a resurgence of interest in manufacturing, and it's really driven, I think, principally by two things. One, the feeling that we perhaps lost too much manufacturing, and that's contributed to some sort of unease and populist uprisings. But the second and most important is obviously China. China is just an unprecedented competitor. When you look at what's going on in Made in China 2025, it's really phenomenal. We issued a report about 2 weeks ago looking at robot adoption in the world, and we controlled for wage levels. So if you're a low-wage country, you shouldn't be adopting that many robots because they're expensive and they cost some money. And if you're a high-wage country, you should be adopting a lot. When you control for wage levels, China is fourth in the world in robot adoption, and they're on track to lead the world, including beating Korea, who's number one, in the next 7 years. So this is not just a country that's competing on low wages. We were talking earlier about how China has copied our own National Network of Manufacturing Innovation, or Manufacturing USA network. So I think that it really is incumbent upon us in Washington, and particularly policymakers, to take this threat very, very seriously. Because if we continue to lose manufacturing capabilities, not only do we lose the jobs and the economic productivity that comes with that, but clearly we run a serious risk of damaging our national security capabilities. And so, to get to today's point, SMEs are super important in that. They account for 98% of U.S. manufacturers. There are a lot of big companies. You'll hear at least from a couple this morning, GE and Rockwell. A lot of big companies in the U.S. are doing really a great job on this. They're advancing the technology. They're adopting it. They're using it in creative and interesting ways to gain competitive advantage. Because they have the resources and this talent to be able to do that. But it's really that 98% that we should be thinking much more strongly about. And so our first speaker this morning is someone who can really, I think, address that point really, really well, and particularly in the context of how is this playing out in other countries that frankly are more advanced than we are in terms of building an ecosystem for support of high-performance work organizations in manufacturing. Dario Rey is the Director of Corporate Research and Innovation for a company that we just call IMA, but I'm going to get the pronunciation wrong, Industria Machine Automatisch. Pretty close?
Yes, automatic. Yes, because we produce automatic machines.
So I got the translation right, automatic machines. So actually, they are a really fascinating company that Stephen Nizell and I had the pleasure of visiting last year in Bologna and Italy. And they make really, really complex machines that do these things which you think are, how do they do that? So I had a cup of tea this morning, and it was in a tea bag, and probably the odds are 70, 80, 90% that tea bag was made on a machine from IMA. I visited Celestial Seasonings with my family last summer in Boulder, and I'm doing the factory tour, and I'm like, hey, that's an IMA machine there. So, but it's a complex technology, which Dario will talk about, and it involves many, many suppliers. They themselves are kind of a large, mid-sized company, but they have partnerships with many suppliers. And I think what's important about what the Dario's experience and IMA in particular is they really are a high-performance manufacturing organization. They partner very deeply with other companies in the region. They partner very deeply with the provincial government, who provides technical assistance and training and the like. So I'm really looking forward to hearing from Dario. He has a long background in this space. He's responsibility to test and manage new technologies for future machines and services development. He also leads IMA's Digital Steering Committee, including a focus on smart machines, IoT, or in this case IIoT, Industrial Internet of Things, data organizations, digital twin, and robotics. And he personally has more than 25 European patents in industrial technology. So, Dario, if you can kick us off.
Okay, thank you. Good morning. Thank you, Robert, for the very nice presentation, and thank you also to Stefan for the invitation. And so I want to start to talk a little bit. I think that I have just 10 minutes, give an overlook about the IMA Group, what is in Italian is IMA, it's not IMA, so to say to you what we are doing. The second point is to show our ecosystem, so how to work in the region with all the stakeholders. And the third point is a challenge, that is the digital transformation, because we know that our company have to be transformed. So I start with a little bit of note. So IMA was started in 1961. It's strange because it's different from the German company. They have more than 1 century. As in our territory, usually after the Second World War, we have a burning of a lot of company. The interesting thing is that we are in the stock exchange of Milan since the 1995, but we have a family, the Vacchi family, that is the real owner of the company. Because they keep the 55% of the share. It's very important because also Alberto Vacchi, that is the CEO of IMA, is in the territory, so he knows the importance of the territory, so to work with all the all the stakeholders. The size, the turnover last year was 1.4 billion. Was quite good, but we still growing, and also the number of employees, more than 5,000, where the 50% is abroad. So that I think that they push too much. The various fields, so 1.4 billion, it seems that we are a big company for the Italian size, but in reality we work in niches. We have many type of different products that we can produce that are in complete different market. In general, we consider that one niche is as a division that has a turnover that is around 100 to 200 million. The bigger part are the pharma, where we have 3 divisions, so around the 40% of the turnover is made in this area. Other interesting, like Robert said before, tea is we are leader 70%, but the world market is 100 million per year, so it's not so high. Plus we have the coffee, so that is a problem of packaging, because packaging now we move from the mass to the mass production to the mass customization. So every machine in some division is unique. So that is one of the problem, one of the challenge. So the coffee pod and coffee capsule, We have automation. Automation for us is the assembly of the part like the medical device. Medical device need assembly. One interesting thing is the tobacco. That was a startup. It started 7 years ago by just an idea of a new machine with a lot of automation inside. And it grow a lot. It gets also the wave of the electronic cigarette. So the electronic cigarette is a closed world where a lot of patent can protect the market. So in 7 years they grow to 0 to 150 million of turnover, and was put in the stock exchange of Milan last year. Now is a public company, and the value was 1.2 billion. So it was a very big, we can say, a success story. The plant, so the complexity is here that we have a lot of plant in Italy, but also in USA. So we have IMA North America that is near Boston, that for assembly pharma machine and to sell, to support, to service the coffee machine. Life North America is the excellency point is for freeze dryer, is in Tonawanda. Is very, they have more than 100 million of turnover. The Delta system that work in packaging flow pack, it was a part of Ilapac, a Swiss company that we bought some years ago. So that is a division, very nice, very skilled people, and that is in Rockford. And the last one, IMA Automation USA, that is near Chicago, is at around 1 hour driving. And they work in assembling, so for example, medical device. Here is the division of the turnover. We can say that just the 10% of the turnover is in Italy. All the other is abroad, is in all the world. And I think that is the trend, the growing trend. That is a problem because we have to hire people. So the problem is find people. We work a lot, but we have a growing tendency for the pharma. The big increase of the turnover in tea and food and water was also by acquisition. Usually when we talk about growing, the idea was to reach 2 billion in 2 years by the 50% internal growing and the other 50% by acquisition. Okay, so this is IMA. So now we are talking about the ecosystem. So stakeholder, if you consider stakeholder, we have a lot. So a lot of connection that we have with the territory, the institution, the political, and also the people that work on our organization. It's not easy, but it's clear that it demonstrates the fact that we are integrated in the territory, and is important because of the territory, it permits to us to grow. The competence in the territory are the motor of our growing, and also are a limit, because talking about vision system, machine learning, artificial intelligence, in our territory we don't have. We can make cars, we can make Ferrari, we can make Ducati, motorbike, but other type of competence are not in our territory. So now IMA is still becoming global, so we start to look also in USA what is possible to do, because we have a lot of center of competence in different type of technology. So now I want to talk just about some of the stakeholder. So that are the number of employees last year, so more than 5,000. We have around 500 in Americas, I don't know, in US. We have also one company that we bought 2 years ago in Argentina, that produce tea bag, very low cost tea bag. But we want to grow in this territory, USA. But the interesting thing is what is the effort that we do in our company to train our people, considering that usually in our company, especially in Italy, the employees stay for their working life. So if you consider the number, if you consider that we have a medium value of hour of training that is 16.6 per employees, is a big investment that we have to do. When I talk about training, is training for safety. That is one of the most important things, but also training for the new software and new competence that we have to create. If you talk about additive manufacturing, it's something new. That is something that is transversal in all the design work that start from the design point of view, so need a different software, but need a different organization to put the geometry of the component in the manufacturing level, but also need different competence in producing the part that is not a CNC, but is something completely different. So we still continue to train people because it's normal. If when I hire one young guy, I say, okay, you start now, but when you're going to finish? You finish in 2060. So that is. So in 40 years, I think technology are going to change a lot. Sure, that is an opportunity, we can say. The other indication, last year we hired around 200 people. In the last 4 years, following the growth, we hired a lot of people, and so that is not easy. It's not easy because in general we can say we work with many schools, also with the medium school, because we have a lot of company in Bologna, in our region. Also Philip Morris International has decided to create a green field in Bologna for the electronic cigarette. And so they are people. So we have a problem that usually technology work in this field is considered, like you say, dirty, dark, and dangerous. So we work also as we are going to school, we open our company to demonstrate to the parent to how it is different the manufacturing by the old idea of that. So to hire people, we work mainly with the University of Bologna, but by the shortage of graduate in mechanics, especially in automation, that is software, we take people also from the south of Italy because they don't have company. We have technical school, where Isaldini Valeriani is a very old school. In Bologna we have two technical schools. Usually the graduated people are going to work in the technical office, and the people that came from the technical school, they work on the manufacturing. Okay. And one interesting activity is the ETS Maker was another school after the high school is a 2-year school that is created by the region and all the company that we have in Bologna, also competitor, and where we put people that we have many different type of this school. For example, in Modena are more linked to the motor, to the car industry. In Bologna are for packaging. So we have people under the high school that stay for 2 years in a school that is made also by the company to permit to have people that are already trained for our job. So that is, I think, that is an interesting thing. The supplier. So the supplier for us are technological suppliers. So it's here that are very important for us, because especially 10 years ago, when we had the crisis, we decided to invest in those companies, having a big, a small sharing around 20-30%, but giving the possibility to this company to think of their technology. So now they are around 20 companies. What is interesting in our machine, in our field, usually when we have an order of plant, we have a delivery time that is around 12 months or 24 months. So the cash flow is very important. In this case, we create, we can say we invented this system. We share with our network the same cost of money of our company. So in this manner, we can have a longer paid of the component, having the possibility to give at our network of company the possibility to have the money from the bank. That was interesting. A second point is the partnership. So now, instead to all those companies, instead to work with IMA, they work all together, so they can create a network that can solve our problem without do nothing. So that is very interesting, because IMA can be focused on the product, and all those companies, they are focused in the technology. That is very important. That here, no, I made this modification this morning. So in the right, we have the growth in 10 years of the turnover from around lower than 20 mil. No, that is the number of employees, from 150 in 10 years. Now they have more than 600 employees. And here we have the turnover that is under 20 million to, no, okay, that is another, but is around 180 million. So it's a growing in 10 years. We create a big growing also in the territory, and that is very important, because if IMA want to grow, we need to have also the growing in the territory. The last point is the digital transformation. You see, just some concept, what the customer want, self-adapting machine, like I said, the future for a lot of multinational in Europe is to don't have people that can operate in front of the machine. That is a problem, a shortage of people. So reduce the unplanned stoppage and maintenance, we can say predictive and prescriptive. So the idea for the future plant is to reduce the low-skill task, and what I said before, to react at the lack of the manpower. That is mandatory if we want to keep manufacturing in high labor cost country. That is mandatory. So different point of view. This transformation is big. Instead to think just at the machines, think at the machine plus data is something that is completely different. There is a very different mindset. Data, I say because everyone talk about personal data, GDPR, that could be a problem. But we are talking about something else, that are the manufacturing data. And who owns the manufacturing data? That is a question. And if you talk about IoT, that is a problem. So the barrier for the industrial IoT are the need for standard. For example, one of the standard is an American standard that is the PAC-ML. That is a standard that permits to describe the status of the packaging machine, of the machine. It's very interesting, but normally is not used. All the company want, but I pass through. I was too fast. So, but is not enough. Is not enough. Second point is cybersecurity. Third point, all the company don't want to share the data. That is, I talk Nestlé, Unilever, and Johnson. No. Last point, that is for the digital agenda. Data is the resource which is shared between company, so contractor and customer, and has the potential to deliver the ROI of Industry 4.0. So just with the data delivering can permit that. Second point, smart legislation should enable data-driven innovation. So up to now is a barrier because no one wants to share the data. Final point, I can say the opportunities. So thinking at data, we can have a continuous improvement of the product, increase revenue because we can catch one part that is the service. Equipment as a service and pay for performance could be one of the future. Some company they ask, but we don't want, because for us means instead to leave the machine at the site and test, we have to keep in our company all the life of the machine. That is a completely different mentality. Move the future from connected machine, smart and autonomous machine. That is the dream. Challenge, new skill like STEM, artificial intelligence. We think that we can use, we started to use. The STEM, we have to start to create this competence, and having also the competence to analyze the data. That is what we see in the future. And so that could be a very big barrier of the evolution of small company. Is a big barrier because the data mindset is completely different. So that is all. Thank you for your attention.
Great. So that was great. I just want to ask you one question before we turn it over to your Director Compton. What, you know, Sue Helper is going to be on the last panel, who was in the Obama White House, and Sue's written this great work on high-performance work organizations and clusters, and you know, and what she talks about are firms that engage in deep and sustained training, firms that support the establishment of sort of shared infrastructures that help the entire system, like ITAS Maker that you talked about. Firms that engage deeply with supplier relationships, and not just hands-off, you know, give me this widget for 6 cents less, or I'm going to cut you off. You're doing all of that. I would just be curious, in maybe less than a minute, is this some sort of thing that just in the wine in Bologna that everybody does it? Or why are so many companies doing that in Italy and in your region in particular?
I think that is in our region because it's a good ecosystem. I think another important thing, a lot of companies are, they have a family. So we have IMA, that is Vacchi family, there is Marchesini, that is our competitor, that is Marchesini family. Also Coesia Group is Seragnoli. So we have, we know all of us. And so by company, we try, we are competitor, but we try to cooperate. Plus the region, we can say that is a region that work in our direction. So I think that is the ecosystem that is the winning answer, because it's difficult to create the same ecosystem in other place also of Italy.
All right, well, thank you so much.
Okay, okay, thank you.
So it's my pleasure now to turn the podium over to Walt Koppen, who is the director, a relatively new director of the National Institute of Standards and Technology, and also in that role he is the Undersecretary of Commerce for Standards and Technology. Walt was confirmed by Congress in October of 2017, so about 14 months on the job. He provides obviously oversight and direction for NIST, has a long career as a science and technology executive both in the business sector, government and nonprofit. And I think what's really great about Walt, besides just what a wonderful, nice person he is, and certainly his technical competence, is his deep commitment to manufacturing as a NIST director. He'll tell you a little bit more about that. He led the Trump administration recent efforts on manufacturing strategy, and so please join me in welcoming Walt Koppen.
So thank you so much, Rob. Thank you, ITIF, for always hosting interesting conversations. And I look forward to our discussion today. We won't have a lot of time, I know, for Q&A. Just a quick time check. How much time do I have? 15? All right. We have witnesses. I don't have the atomic clock with me, however. But I'll be focusing my remarks this morning around the Advanced Manufacturing Strategic Plan recently released that represents a strong interagency effort and probably one of the best examples, I believe, of cooperation across federal agencies through the National Science and Technology Council. We are, as a nation, facing intense global competition. Manufacturing is the driver for that, and is very clearly set up in the opening comments that Rob shared today. The strategy for American leadership in advanced manufacturing was developed by a team that actually included all federal agencies that have an interest in manufacturing technology, development of supply chain, and of workforce. And NIST was privileged to co-lead this team along with OSTP and the National Economic Council with core membership of 11 other federal science and other agencies. As we all know, manufacturing plays a crucial role in every sector of the U.S. economy, stretching from aerospace to pharmaceuticals to advanced materials and far beyond, many of the examples that were shared earlier by Dario as well. And advanced manufacturing, which includes both new methods of production, the digital economy, enabling innovation, interconnection, automation, is truly the engine of America's economic power and a pillar of national security. And we have seen in recent years that rapid advances in technology combined with economic forces are changing the ways in which products and services are delivered, designed, made, distributed, and new business models behind them. And so the growth of advanced manufacturing requires advances in technology-based infrastructure, includes investments in new technologies, in education and workforce, in expansion, modernization of the supply chain, and in building our ecosystems for innovation and manufacturing. The strategy for American leadership in advanced manufacturing was developed with a lot of public input, a lot of stakeholders gathered through both a request for information, formal responses, and a series of regional roundtables held with a diverse array of stakeholders around the nation. And I would like to say I really appreciate ITIF and your engagement, your thoughtful inputs as ever. So thank you, Rob, Stephen, and the entire team. The structure of the strategic plan is such that American leadership in advanced manufacturing across industrial sectors to ensure national security as well as economic prosperity. So there's a strong element here of the defense supply chain, but also the recognition that economic security translates to national security. The vision will be achieved by pursuing three goals. Some of you may have picked up a copy of the hard copy of the strategic plan, but it is available online. The contributing organizations are also listed there, and we're grateful to each one for their contribution. And so the underpinnings of the vision are threefold: to develop and transition new manufacturing technologies, to educate, train, and connect the manufacturing workforce, and thirdly, to expand the capabilities of to the domestic manufacturing supply chain. And each one of these goals, as in every appropriate strategic plan, is supported by a series of objectives, and then for each objective there are a series of actionable technical or program priorities identified with the actions to be accomplished over the next 4 years. So this is a plan that's intended to take the United States through 2023. So I'd just like to bring your attention to some of the elements of the plan. We clearly won't have a chance to go into too much, and I'd like to also share some of the ancillary work that's going on involving NIST and others that relate to U.S. innovation and ecosystems of manufacturing. So the first of these goals emphasizes the importance of new technologies to develop and transition manufacturing technologies. And underneath this, there are 5 objectives that have come out of the national strategy process. So the 4 national priorities underneath these, we have, and let me just focus on the intelligent manufacturing systems. So smart and digital manufacturing, advanced industrial robotics, the infrastructure for artificial intelligence, and cybersecurity for manufacturing are essential elements of our strategic technology goal. And as some of you who know NIST, you realize that we have programs in each of these areas and many collaborations across the public as well as private sectors. And so to do a deeper dive here into the area of cybersecurity, which Dario also mentioned, it is certainly a critical element of industrial IoT that the U.S. manufacturing sector and the elements of the supply chain, which are, of course, becoming increasingly vulnerable to cybersecurity threats, that we must, throughout the system, enable the strengthening of cybersecurity practices and tools as well as workforce. So continued R&D is needed on standards and guidelines development for cybersecurity. Certainly NIST has been involved in the development of such standards as well as building upon the cybersecurity framework, which was released in a substantial update in April of 2018. So this includes AI for threat detection and handling, blockchain for the security of sensitive manufacturing information, and security of the industrial Internet of Things devices. An important tool for NIST and for the nation has been the utilization of the manufacturing extension partnerships. Yes, some of the people who were there have gray hair. I regret that I was personally unable to be there for that celebration. We were actually in Versailles at the time for the redefinition of the international system of units, a great accomplishment for the United States and for the member nations of the Treaty of the Meter. I'd also like to say that Manufacturing USA, for example, DMDII, from whom we will hear later, operates a national center for cybersecurity in manufacturing that focuses on building awareness, capacity development, and also the provision of low-cost tools for the small and medium-sized manufacturers for our nation's supply chain. We also know that there are some challenges within the defense supply chain just simply because of requirements for small business procurement, but that in itself creates challenges because some of those companies do not have the internal capacity, so the utilization of the national networks for cybersecurity and then the deployment regionally is a critical element for the nation. So the second top-level goal of our national strategy is to educate, train, and connect the manufacturing workforce. It's a massive undertaking, and I've had conversations with friends at the National Academies of Sciences as recently as yesterday about integrating the feedback that's been received through the Advanced Manufacturing Strategic Plan with the other elements of workforce for the nation to cascade through our STEM education programs and through our university as well as community college curricula. So there are 4 objectives under the education and workforce goal, and there are 3 national priorities under manufacturing workforce. The first is manufacturing-focused foundational STEM education. So part of that is creating awareness and creating incentive for STEM education and for career tracks. The manufacturing floor is very different from what it used to be, right? I was in Singapore last week and visited the A-Star facilities for digital manufacturing, and it's quite a great test bed for the Asia-Pacific region. It's critically important for us to have these public-private partnerships within the regions in this nation to drive manufacturing, engineering education, as well as industry and academic partnerships. Manufacturing-focused STEM education is a critical element, but we can also see that there are significant disconnects between what schools teach, the type of skills that are required in manufacturing, both now as well as reskilling anticipated for the future. So we need to develop our talent pipeline strategically in a way that's ready for the advanced manufacturing jobs based on new technologies and based on industry roadmaps and technology adoption characteristics. So again, this is an area where NIST has been very active in the development of the semiconductor manufacturing and workforce roadmap. But there's much work to be done across the nation, and the approach of integrating these individual efforts is very important for us to take that next step. The work of the Manufacturing USA Institutes, and a shout out really to each one of them and our Advanced Manufacturing National Program Office, has been tremendous. Since the formation of Manufacturing USA a bit more than 4 years ago formally in the RAMI legislation, which is now ready for a revisit, the impacts of the education of our workforce have been growing exponentially. And we've seen on the order of 250,000 students and teachers engaged in manufacturing-related projects through cooperative programs, internships, certifications, and training. But there's so much more yet to be done, and to build the capacity to support the demands and the diversity of the future workforce required in the United States is absolutely essential. So the third goal is to expand the capabilities of the domestic manufacturing supply chain. And here, underneath this goal, certainly the vast majority of our manufacturers are small and medium-sized. They are crucial to ecosystems through the supply chain, and therefore it's absolutely crucial that they participate fully in the advanced manufacturing sector. And underneath this goal, there are a series of core initiatives. The first is to increase the role of small and medium-sized manufacturers, but secondly, to encourage ecosystems of manufacturing innovation. It's exactly the focus of our program today. What are the elements of the ecosystems? How do they work together most effectively? How do we balance the equities between the parties? And how do we fill the gaps such that we have healthy, vibrant ecosystems? And so let me focus on this area just a little bit more. Certainly we see these programs of where NIST has an engagement. NIST is the organization within the Department of Commerce and really for the nation that has industrial competitiveness as part of its mission, in addition certainly to leadership in U.S. innovation and measurement science. So ecosystems require agility in gaining new capabilities. They need a source of technologies. They need to have close access to the educational institutions, to talent, to end-use markets as well. And certainly the Manufacturing USA programs, which has been mentioned, have been replicated in other parts of the world. Certainly, imitation is the sincerest form of flattery, but it also creates great competitive advantage for those who adopt best practices. And so I'm proud to say that the MEP, Manufacturing USA, the Baldrige Performance Excellence Program, which recognizes our top organizations in the United States, are all part of an ecosystem as well of creating value for the United States, and the ability then to drive capital at the interface to incentivize that is an area I know that also ITIF has been very engaged in looking at perhaps new policy instruments that would be appropriate for this nation. So part of these initiatives include R&D transition, technology transfer, and tech transfer is not what we envisioned it at the time that the Bayh-Dole Act and the Stevenson-Weidler Act were issued in 1980. A lot has changed then. Those are the days before the digital revolution, right? So many of the aspects that we're talking about today require modernization within U.S. legislation, policies, and best practices. So we announced earlier this year the creation of the ROI Initiative with a request for information and national conversation. And we are preparing now for the issuance of the results of that national conversation within this week. It will be a draft green paper that's responsive to the President's management agenda. This is something that NIST has the national responsibilities to lead in our role for leadership in technology transfer and commercialization policy for the nation. And so we look forward to continued engagement with ITIF and with the community in response to the feedback of our national conversation. There are great opportunities that don't require legislative change. Creating a more entrepreneurial R&D workforce within the federal sector is sometimes challenging, simply because we have to deal with conflict of interest and ethics requirements for federal employees. But there are recommendations that are coming out as a result of our green paper that I look forward to additional comments on those approaches that would create the greatest potential value. So we've had a quick walkthrough of the strategic plan for the nation. It has a 4-year time horizon. We're not calling it America 2024, but we certainly have a mandate for action in this nation. This administration is focused on manufacturing as a key element and workforce. The federal agencies, and you can see listed here, have a broad range of engagements, and we're looking to continue to synergize the great effort across the federal sector and between the public and the private sector to achieve the great results that we're seeking in advanced manufacturing for our country. Thank you.
You were good on your 15 minutes. Thank you. I think we probably have time for just maybe one question for the director. If anybody wants to take a jump at it, or right here, and if you can wait for the microphones, identify who you are.
I'm Chuck Wessner with Georgetown University. Just a simple question: Do you have the resources you need to do this, and do you expect to have any continuity in those resources and increases over time? I mean, MEP has been a great success, but it has struggled for the resources.
Yeah. Thank you so much for that question. The answer to that is not yet. So we have great, dedicated, powerful resources, but in view of the global competitive landscape, I believe that there's time for the community to come together and to look at sustained levels that are required, as well as a constancy of purpose, regardless of administration, to ensure that we can achieve these great goals. We get by with a little bit of help from our friends.
Okay, great. Well, thank you so much.
Thanks so much.
Okay. So if I could ask the panel to come on up and join us here. I will turn this over to my colleague Stephen Ezell, who is going to lead this panel. We also should have plenty of time for discussion and comments and questions from you all. Stephen is prolific in his analysis and writing on advanced manufacturing. If you haven't seen his work recently, he's written probably 3 Yeoman's Reports work on smart manufacturing or IIoT or Industrial 4.0 or digital manufacturing. Not that we're hawking this or anything, but why digital manufacturing matters and how countries are supporting it. And then another one, manufacturing digitalization, the extent of adoption and recommendations for increasing penetration in Korea and the U.S. And one of the things I think that's so interesting about both of those reports is when you really look around the world and look at global best practices in this space. Certainly the U.S. has some of those, but other countries have a lot as well. And so we're going to talk a little bit about sort of what that challenge is all about right now.
Well, thanks, Rob, and good morning. I'm Stephen Ezell. I'm the Vice President of Global Innovation Policy here at ITIF, and I'm going to lead our first panel today on how manufacturing digitalization is transforming the landscape of global manufacturing competition. So manufacturing digitalization refers to the application of a wide range of modern information and communications technologies, such as sensors and IoT, big data, and artificial intelligence, advanced robotics, to modern manufacturing processes. It matters greatly because ICTs account for 25% of manufacturing inputs across the U.S. economy and as much as 40 or 50% in some sectors like cars or electronics. Collectively, manufacturing digitalization is going to transform how products are designed and developed, how they are fabricated and assembled, how factories integrate and operate, how supply chains interconnect, and how products are used and sold in the field. They also, because they have the ability to democratize the means of production and make lot sizes of one possible, or mass customization. And this means that it may be possible to make more manufacturing competitive in traditionally higher cost manufacturing environments, and that's really shift the landscape of where manufacturing occurs across the global economy. Now, despite the potential for these technologies, the reality is that still 77% of U.S. SMEs have no plans to even implement industrial Internet of Things within the next 3 years. A McKinsey study finds that fully 50% of large U.S. manufacturers, quote, have no systematic digital roadmap or toolbox for easy rollout of digital manufacturing solutions. So while there's potential, there's much to do to get our workforce and our ecosystems ready for the potential of these technologies. So we have a great panel to discuss this today. I'll be brief on their introductions for time, but we're going to start off with Sean Manzanares, who is a senior manager with Autodesk, where he's responsible for driving the go-to-market strategy of Autodesk design and manufacturing software portfolio within North America and the Asia Pacific. He has 20 years of experience across the industry in CAD and mechanical design. After Sean, we'll hear from Dave Vasco, who is the Director of Advanced Technology at Rockwell Automation, where he's responsible for applied R&D and global product standards and regulations. Dave also serves as a member of the NIST Visiting Committee on Advanced Technology, or VCAT, and is on the boards of the Smart Manufacturing Leadership Coalition and the Milwaukee Institute. Lastly, bringing up the reeler as our anchor marathon runner is China Brown, who is the Executive Director of the Digital Manufacturing and Design Innovation Institute in Chicago, one of America's 14 institutes of manufacturing USA. Before joining DMDII, she served as CEO of Brown Executive Strategies, a strategic consulting firm, and Green Endeavor, a clean energy consulting firm. Previously, President Obama appointed Chandra to serve as the Deputy Assistant Secretary of Manufacturing for the Department of Commerce, where she managed a broad portfolio of programs aimed at increasing the international competitiveness of U.S. manufacturers. With that, let's have a discussion about manufacturing digitalization. Sean, the floor is yours. Thanks.
Thank you. Good morning, everybody. Thank you for having me. As Stephen just mentioned, my name is Sean. I work for Autodesk. Is there anybody familiar with Autodesk in the... That's excellent. So I work in the business strategy and marketing, as he mentioned. It's about not really just about the go-to marketing of the products. It's really about understanding where design and manufacturing is going over the next 1, 3, or 5 years, and understanding how we can map our products to assist the community. We have one mission, and that's more, better, and less. But it's much more than those three words. It's how we can help our customers do more and do it better with less negative impact on the world, on the planet. So when I be going through our presentation, you're going to kind of see some references back to this. When I was looking at the syllabus of what we're supposed to be talking about, I thought I'd just pull out exact nuggets of where we're going to go and speak about today. How manufacturing digitalization is transforming the landscape of global manufacturing competition. So there's been discussion today about how different companies are using manufacturing. I'm going to go upstream a little bit to the design of it, because with Autodesk, we want you to be able to make anything and design anything. And when you look at the software application that is there. So as we go through this, competition is very fast. And I love this photograph because it connotates speed. It connotates there's a first, there's a second, there's somebody that's leading, there's somebody getting clean air. So just as we deal with the small, medium enterprise companies, or even major Fortune 100 companies, they are in a competition with each other. Now, does the car in front, do they have the right technology to keep them in first place? Or maybe the car in second place is going to slipstream and come around that. So it's all about access to technology, and it's also about having the right technology. So what we do here at Autodesk is provide you the technology tools to make sure that you're going to get the two things, competitive separation and competitive differentiation. I can come up here and tell you our vision of what everything should look like, but just like you probably subscribe to a lot of newsletters like we do here for ITIF. I subscribe to Forbes, and I saw this article that says 9 mega technology trends and how they're reshaping our world. And I thought, what is going to be in these 9 trends, and how can we map this out to the small, medium enterprise businesses? So you take a look. It's all over the map, from data to blockchain to platforms to artificial intelligence to user interface. There is a lot happening. Now, can you imagine if you're a small company, 100 employees or less, or if you're 5,000 companies? How are you going to tackle all of this type of technology? It is rocking your world, and we recognize that, and we see that those are disruptions. Those are disruptions to your business and your processes, and will affect your end output. There's 3 things that these disruptions are. The means of production, we talked about that. No longer going to rely on the old methods of stamping and machining and milling. There's new ways of production that is happening today. Now think about it. Production is the actual manufacturing of the parts or components. It's got to go upstream into the design side of it. We're looking at the hyper-connectivity. All of us are connected. The shop floor is connected. The design team, the research and developer team, everybody is connected, and those tools are connected in a new way that we have to acknowledge. Once again, you can look at it, either you're being disrupted or you're going to be disrupting with this technology. Finally is the changing nature of work. So historically, been doing some millings, the CNC manufacturing, but we have to recognize that there is changes in the way the nature of work is happening right now. There's an aging workforce. There's new technology that's coming, and I'm going to talk about some of the things that we like artificial intelligence. How do you grasp that? So how these technologies are enabling new forms of value creation and cost-efficient production. Here's a list of the 9 trends. We're going to take a look at the computing power. Now, I personally went to Oak Ridge National Laboratories about 9 months ago, and they're in the 1%er. They get access to these super computers to do their work for them. But how does that happen? The rest of the 99% of us. You're not going to have a company, let's say there's 1,000 employees, that are going to invest in capital equipment, put it down the hall, and have an IT team to go and deal with broken machines or software updates. It just doesn't make sense, but we should all have access to that same computing power. So if you're not familiar with HPC or high-performance computing, it really does allow scientists and engineers to solve complex compute-intensive problems. But it's never been accessible. And there's no way for you to be able to be competitive if you don't have access to this HPC. I saw this from Wired magazine. I love it. It's a supercomputing for the 99%. This is about elastic computing, so it's always on, but you only get it when you want it. So when you go out and you ask the cloud to do something for you, and you bring it back down. So now you're being able to roll this out to a wide range of people. The next one is artificial intelligence. You walk down the street, somebody's going to take a picture of you, and there's some artificial intelligence there. Artificial intelligence is all around us. But what I want to focus on is what artificial intelligence is on the design side. Remember, we make software for people that make things. So we want to be able to have that artificial intelligence in the beginning. I've been in the design world my entire adult life. So historically, if we needed to create this podium or that projector, you get a team of 5, the front row here. And what we want to do is we want to come up with that best product because we have to take it to market. But we are limited of what our designs are and that what we put into the system. We might have 5 different variations, right? But is that one of the 5 variations? Is that the one that's going to make us have that competitive separation and competitive differentiation once we go to market? We're limited on what that is. And this is the old way of doing things. When we look at the new way, this is the old way where you might have a half dozen designs, right? You go into validation, you have to, can we even make this part? And that's going to be our end product. So now if we look at this, I'm limited. What we're seeing is a change in being able to leverage machine learning, algorithms, artificial intelligence to create the design for us. So now I have literally hundreds, if not thousands of different options of my design. This is a swing arm for a motorcycle. So you have the traditional methods of us or me putting in my ideas, but now we're going to a totally new area where we're leveraging the cloud, this high-performance computing. No longer do we have to have a supercomputer down the hall. So now we're leveraging the cloud to give us our designs. I'm going to watch one short video here to describe this.
What if you could come up with thousands of options for a single design without drawing, all of which meet specific goals set by the designer? From those options, pick one design that delivers on the most important criteria, a design you couldn't possibly implement. This is generative design, a technology that harnesses massive computing power, creating forms with precise amounts of material anywhere in the network, achieving maximum performance always dynamic. Generative design can be about much more than simply trying out alternatives. Prototypes can be scanned and equipped with sensors that provide real-time performance data and feed back into the design process so the object, in effect, co-designs itself. And depending on the material and method of manufacture chosen, the software can optimize the design for those choices. In its search for the optimal design, generative design creates complex forms that would otherwise be impossible to create using traditional manufacturing methods. Now with advancements in material science and the ability of 3D printers to print metal, companies like Airbus can create forms like this airplane partition panel that's half as light and just as strong. Result, significant reduction in fuel costs and CO2 emissions. The things that have limited us in the past, software, materials, manufacturing, no longer do so. With generative design, the world can look and perform any way we want it to. This is the next stage in the evolution of design, and it's happening now.
So when you look at one of the technology trends, right, which is artificial intelligence, this is harnessing the artificial intelligence at the design portion of this. So the product hasn't even been made yet. But historically what you've had to do is you'd have to run a lot of different validations, a lot of different prototypes to figure out, is this one going to work? If I drop it, will it break? Where will it break? What's the strength? So now we're taking advantage of that from the cloud using artificial intelligence based on loads, weights, stresses, how we want it to look, how we're going to manufacture. Are we going to cast this? Are we going to machine it? We're able to take all of that up front, and now that puts us in a position to win. Because now I can go to my management team and say, listen, I have 30 different ideas for this new design. And if you look at the red ones or the blue ones or the green ones, these are going to give us the best yield. So what I've done now is I've shortened my time to market. I'm getting this competitive separation. Not only am I having the best product, but I'm getting it out there faster than my competition. And that's what it really is all about. The last topic here is how firms need to and can adopt manufacturing digitalization techniques. And this is about interacting with technology. So we're going to use this example that was recent from General Motors. They have a vision to be an all-electric vehicle by 2023. And I don't know if you have a hybrid or an electric vehicle, you want it to be a little more lightweight than the regular weighted cars. So what they want to do is they just want to start lightweighting their vehicles. And one of the ways they're doing that is they're taking a belt buckle assembly. We've all rode in a car in the back seat, and you've seen this. And what they wanted to do is they wanted to start here. Think locally, act globally. Now look at this part. It's a subassembly. It has 9 components to it. There's sheet metal. There's hardware to it. There's some parts that were come from their tier suppliers. They wanted to take this and make it lighter. But to make it lighter, it has to still be as strong. That's functional when you look at the vehicle. So they ran through artificial intelligence. They came out with dozens of different design options. Now when you look at it, the design option came into one component. So not only did they remove 8 components, they went from 9, they went 8 components into one part. It's 40% lighter and 20% stronger. So now you can see if they take that idea and they move it to other parts of the vehicle, how they're going to be able to lightweight that vehicle to see what their overall mission is of electric vehicle futures. So 3D printed seat bracket into one component. This video shows it all together. So when you think about the design, think about artificial intelligence, taking the 9 down to 1. There is no human on this planet that could design that. The only way you can get that structure is through artificial intelligence and leveraging the cloud and the high-performance computing. And what's important to understand is this is for General Motors, but don't think of it as for General Motors. It is available for every person, whether you're a 5-person engineering team or you're a Fortune 100 company. The technology is available today to make your machines or your designs better. So when we look at 3D printing, I was with the gentleman last night, Paul Hughes of GE Aviation. 30,000 of these nozzles are on airplanes. 5 years ago, you're going to tell me that I'm going to fly across the country from San Diego and they're going to have 3D printed parts on an airplane? This is what's happening. So 3D printing is here today. It's going into production, whether you're making shoes like Under Armour or engine blocks like Toyota, and you look at this lattice structure, once again, there's no human that can design this. You have to have the technology using generative design and artificial intelligence. And this is the swing arm, and finally the General Motors part. And something that we just showed was the Airbus partition. Now they invented a brand new alloy called Scalmoly. They printed it out. This is half the weight, twice as strong. Now imagine when they start putting this through all the A320 planes. It's going to start using less fuel. And finally, I call this my Mr. Fahrenheit moment. This is the lunar lander. We just released this last week or 2 weeks ago at our conference. This is in cooperation with JPL. This is what the next lunar lander could possibly look like. So we've taken it from a pair of shoes or a GE nozzle or an Airbus partition, and now we're going to talk about putting this on Mars. Last slide here is when we look at this, it's really about the convergence of design and manufacturing. Historically, we worked in silos. I'm the CAD guy, I'm the drafter, I'm the designer, I'm the research and design engineer, and it stays there, and it gets documented. But now that we have data in the middle, we're able to tie all of these organizations into one. Now we take the automation of generative design to help create the best design. And you can't get away from the fact that you have to make the part. If you're only doing design, you're only selling pixels on a screen, and that's not what it's about, because companies have to manufacture parts that they have to sell and make a profit. So we see it from the design, through the manufacturing, all the way through the production, and all the way through all the machines on the shop floor. Today we just discussed 5 of the 9 technology trends that was laid out by Bernard Marr from Forbes. That is my time. Thank you very much. That was a race through the design. I do have one more comment here. We talked about the Manufacturing USA and the investment. This is an example of our investment at DMDI in Chicago. Autodesk is a Tier 2 member. I'm starting to fill it out with an advanced manufacturing lab. It's going to be the world's first generative design lab where we're going to be able to walk people through. So not only are we working in silos in terms of what we're creating in software, but we're also invested as well into DMDI. Thank you for your time.
Dave Vasco, thank you.
Sean, thank you. That was really nice. I enjoy the demos. So I'm Dave Vasco. Let me just. Oh. Is that it? Is there?
Switch the slides.
Pardon?
How about that?
Okay.
We'll get it worked out in just a second.
Okay. So just to start off, I have a confession to make. So I'm a serial hobbyist. That's how I am. I start into one hobby, I just dive in, and I love to jump in and just get into a hobby, and then move on to the next thing, become an expert, move on to the next thing. So I'm the guy that goes to the splash party for scuba diving, where you go to a pool and you take a regulator and you go underwater and you blow some bubbles, and the next thing I know, I'm training as a rescue diver and then off working as a professional dive master, or going to an auto racing event and doing a ride along, and the next thing I know, I'm on the national tour and competing in the national tour. That's what I love to do. And my job really is largely around that as well. So I'm responsible for advanced technology at Rockwell Automation, the tech roadmaps for Rockwell Automation, the engagements on global standards and regulations. Those are all things that are part of my job and I love to do. And I think we're at this amazing time in manufacturing. How many people have read Malcolm Gladwell's Outliers, the book? Okay. I think it's an incredible book. So if you're a hockey player, when were you born? January or February? Because that was the time where you had an advantage over everybody else. If you were born in December, you were so far behind, you're not going to become a professional hockey player. You're born in January, February. Computers, people that really revolutionized computers, 1954, 1955, Bill Gates, Steve Jobs, Bill Joy, they revolutionized the industry because they were born at the right time. In manufacturing, I think that is where we are now. We have all these IoT technologies that are emerging, and they're allowing us to do so many things, but they're not really applicable to many of the commercial items. It's really hard. Beyond cell phones, how much IoT integration is really happening? In manufacturing, we have sensors, we have high-speed networks, we have computing that's available today to take advantage of the technologies like AI and blockchain and all these things that are emerging. But clearly manufacturers need help in doing that. So Rockwell is the largest company dedicated to industrial automation and control and information. And why do we care about small and medium manufacturers? I mean, we have 400,000 products. Can't we do everything ourselves? And the truth is no. That really the value that being created going forward is connecting all the manufacturers together, connecting these supply chains, connecting all the partners together. That's going to be the real value going forward. And that's what really we're concentrating on. So the heart of this is this digital transformation. And we have a lot of talked a lot about this. I think Sean talked a lot about the design aspects of this, and I'll talk a little bit more about how the design aspects and the operations and the aspects around maintainability really play into this. But what we see is these technologies coming in, and these are disruptive technologies. For large companies, it's something we can deal with. It's not difficult for us to deal with because we have research groups. We have large teams that could bring efforts to bear on this. But for small and medium manufacturers, it's so much more difficult to do that. And they really need help in making that transition. And part of this is the workforce as well, training the workforce, giving them the skills they need to go forward and to be able to react to that. And I know Rob has talked a little bit about this, but you hear things like, oh, the robots and AI and automation is coming, it's going to take all the jobs. And I just want to cry. Because we're at a time where we need people more than we ever had. We're at a time we could leverage people in manufacturing more than we ever had. We still have people to come into manufacturing and leave your brain at the door. And now we want people and we want them to be involved and bring their best skills to help us really elevate and make us more productive. I was with Rob at an event yesterday at the National Economics Club, and just talking about the decrease in productivity. We need more and more people entering this, and there's a time when we have people that are actually leaving the area now and leaving manufacturing. They're retiring. We have a lot of baby boomers retiring, so we need people more and more. We need focus far around this as well. So. Dr. Koppen stepped out, but he mentioned America 2024, and I was going to ask, why don't we have America 2024? Why don't we have a focus area? We have this incredible strategic manufacturing plan, which many of the people in this room have helped to create. We have a cybersecurity framework. We have a smart manufacturing framework. We have Manufacturing USA Institutes. We have the MEP program. But we have different names for this. If I go outside the U.S., I can name every single thing that people have done in other areas. 20, 30, 40 countries, we can name their programs. For the U.S., we could talk about individual artifacts. We need to be able to focus things together better than we have in the past. So let's talk a little bit about these disruptive technologies. So we think things like artificial intelligence coming in. And artificial intelligence, we've actually been involved in artificial intelligence for quite a while, tracing our roots back to 1991. But artificial intelligence is very difficult for people to actually implement, to actually be able to push forward. The key for most people is you'll have data scientists that are you doing this. If you train artificial intelligence on a particular data set and you go beyond that data set, different things can happen. It can be very disruptive. So I think being able to apply it to manufacturing, you need expertise in actually doing this. For us, we actually are putting physical boundaries, we call them guardrails, around artificial intelligence. We look at the physical properties of manufacturing. A motor is going to be a motor tomorrow. It's not going to turn into a butterfly. Almost all the AI done today is stochastic data, random data, and it's looking at wild events that can happen. And while it may be good for the internet, for manufacturing you can use a much simpler approach, and that allows you to put guidelines, boundaries on these programs themselves. So that allows us to actually be able to do AI without having a data scientist there all the time. We see blockchain as being a very impactful technology, being able to connect these things together, being able to establish trust. There's a book that was published a while ago called Sapiens, The History of Humankind. And it talks about really humankind being able to evolve. And part of this was actually the having the trust and having these, they called shared myths, where we work together, be it government, be it industry, be it even religion, that we all share this idea. I mean, we come to work expecting to get a paycheck every day, and you're able to do that. Having things like blockchain will allow this trust to really extend beyond. But it's if you talk to many people, they're thinking cryptocurrencies, they're thinking bitcoins. The small and medium manufacturers need help in applying these things. You look at things like digital twins, and digital twins have been a really hot topic lately. And I think it's one of the most confusing things that for people to grasp. So we see digital twins being used in many areas. I see a lot of people taking whatever they're doing and now calling it a digital twin. But digital twins can be applied to the design aspect. They can be applied to the maintenance aspect. They can be applied to the operational aspect. And the best cases, you're able to take data used in the design aspect, like in Sean's tool at Autodesk, take that design data and migrate it to the operate phase and to the maintain phase, and use those models and simulation models throughout. But for small manufacturers, I think trying to apply digital twins is very confusing. I think I have 33 cases where I've looked at digital twins and how they're being applied. And every manufacturer may have a different instance, but you have to make sure you're lined up. You're trying to do the same thing. You're trying to do the same goals.
And Dave, just define what a digital twin is more precisely.
Sure.
So there's you can imagine a jet engine or a locomotive or a gas turbine, and somewhere in the world on an Autodesk piece of software, there's that one initial design of what that jet engine looks like. Yeah. The digital twin is the idea that there is a digital copy of the instantiation of that engine as it exists out everywhere in the world. So talking to the guys from Rolls-Royce, they say that for every jet engine they have, of course, they have the data stream attached to the engine. So they understand exactly the temperature, the humidity, even I've heard the number of grains of sand that have passed through that engine over time. So the digital twin is this notion that, you know, we have a real true to life understanding of the deployed asset in the field, and that enables us to both put a better business service model around it for maintenance, but even build profitable service models for fleet contracts for jet engines.
Yeah, it's a living replica of what was created. My first digital twin was probably 20 years ago. I did automation system in a factory in Australia, and I used a digital twin to actually simulate the mill in Australia. And then when we went into production, I used the digital twin to retain a model. And the production plant, when they switched from one product to another, they could lose up to 10 tons of steel. By understanding what the state of the factory was, we could go directly to the siding and not lose any steel. So I'm going to work through. Look at digital twins. So these are the 33 cases we talked about for digital twins. And so Stephen talked about the case like GE, where you have a twin of a product. You couldn't have a twin of a machine, a robot cell, like Dario's systems. You would have a digital twin there, where you would take your design, work it in the operate, work it in the maintain phase. You could have a digital twin of a person. I've seen digital twins of people with protective gear and what they're exposed to. All these things are digital twins, but for a small medium manufacturer, it's hard for them to understand which one to apply and to meet their needs. I'm just going to touch on virtual reality, augmented reality. This is really going to change how we approach things. It's going to allow a lot more flexibility, being able to go from one area to the next. It's remoting people, bringing expertise. So we use it for example, remote service. You could have somebody put on a headset, go up to a machine they're not familiar with, have somebody at the other end seeing what they're doing, giving them instructions, giving them videos, telling them exactly what to do in order to fix things or to certify things. We can take this and actually do a video, so you can actually keep a record that it happened. You can use blockchain if you want to actually make sure it's immutable. So if you have an audit on what happened and what you did, you can come back to it later. It's going to change how we work. Analytics, machine learning, we talked a little bit about this. I think this is really an area where people are struggling on how to apply it. I mean, AI has been around there for so long. It's a matter of how you apply it, how you could actually deliver value for the small and medium manufacturers. But there are opportunities to do this, and they need some help in actually getting there. Collaborative robots are one of the areas that are changing things. These are allowing people to work together. There's an example with BMW where, actually, I'll give you an example. For first, we look at GM, and we look at where they are and how they've had to cut back on their production, on the people, and their staffing. And they're building vehicles, but it turns out that only 30% of the vehicles sold today are cars. The rest of them are trucks, SUVs. So by not being agile enough, they're having to cut back staffing. BMW actually added people to the production line with collaborative robots so they could switch over the lines very, very fast. And they're able to meet the demands based on whatever's selling this week. If a convertible's selling, you make convertibles. If maybe SUVs are more important, maybe you could switch over and make SUVs. But they're able to switch much, much faster, and that's becoming more important than agility. What we're seeing is we really need skills at all levels. So this is from the Institute for the Future. They're saying that 85% of the jobs will change by 2030. So what you're seeing here is that the ability to acquire knowledge is actually more important than knowledge itself. We need to train our workers such that they can change to different jobs. They can look and see what's happening next. For my research staff, if I were to hire for experience, every 3 to 5 years I'd have to turn over half my staff. I hire people in that can learn very quickly and become experts very quickly. I hired an astrophysicist, and they're starting industrial networks, computer networks. And within 6 months, they will be a world leader in computer networks. And that's really what we need, is people who are able to jump in, learn, and be able to learn quickly and adapt. It means that we use continuous innovation. So we're involved in programs like the CSI, the Connected Systems Institute at UWM in Milwaukee, where we're teaching students coming through at undergrad and graduate level about automation. We're involved in research projects there with the teachers, the faculty, and the students. We have continuing education classes teaching the business leaders, the executives, what it means, because we can train the people all we want, but if we don't have the business leaders thinking of a continuous improvement, it's not going to work out. And then finally, it really takes a village to do this. So we all have to work at this. We're finding ourselves more and more helping to train people. Like we were involved in a veterans training program, the Academy for Advanced Manufacturing, where we're taking veterans, running them through a 12-week training program. People that have had high-tech skills in the service but can't apply them in manufacturing, and we're reskilling them. And our goal is to actually deliver 1,000 people per year to do that. They could be doubling and tripling their salaries, but just seeing the enthusiasm as they are applying the skills they've learned in these environments. And that's the sort of thing we need. If you look at the gaps we're facing going forward, more and more it's going to be important to do that. So just in summary, we talked about these clusters and disruptions and these technologies. We need to help the small and medium manufacturers get there. We need to help them. Like Stephen had mentioned, 77% of manufacturers aren't making this transition. We need to do a better job of actually making those connections and help them. I think we need a U.S. focus, and I would call a challenge. We actually have a U.S. focus. As with Rodney Brooks, actually last month at a VCAP meeting, he told me that Angela Merkel had heard about the German initiative around smart manufacturing, and they had this name that was about 3 feet long, and Merkel said, no. We need something that actually focuses our efforts, and they came back with Industry 4.0. We need something to focus our efforts around smart manufacturing in the U.S. We approach it differently than anybody else. It's innovation. The winner does, the person that has the best solution wins. So we don't try to dictate it, but we need to focus around that. And finally, the workforce. I want to challenge each and every one of you to help us with workforce. If you have a plant or access to a plant or know somebody that has access to a plant, grab a student, grab a group of students, bring a teacher along, take them to manufacturing, show them what it is like today, show them what it is like to be in these enthusiastic places, these innovative places like Dario's facilities and the stuff he's applying. Rob confessed that he went to Celestial Seasons to see manufacturing on his vacation. This is really cool stuff. So
that's expected at ITF.
Yes. So pull people in and try to get them in there. We need people there. There's incredible careers that await there, but please pull them in. If you want to hear more, you can follow me, and I have a podcast on iTunes called State of the Industry, your guide to the future of smart manufacturing. Thank you.
Thank you so much, Dave. Really appreciate Rockwell's leadership in this space. You're a true national asset along with Autodesk. All right, Chandra.
Bringing up the marathon.
Anchor swimmer.
Anchor swimmer.
Runner, whichever you prefer.
I prefer swimmer.
Swimmer, fantastic. You got it.
Okay. Good morning, everyone. Still with me?
They're going to cue them.
Excellent. Oh, they're going to put it forward. Griff, fabulous. So I want to thank ITIF. I want to thank Stephen for his kind introduction, but he probably forgot one of the most important things, which is that I actually am an SME, or was an SME for 19 years. I worked at Oregon Iron Works and United Streetcar. We built boat bridges. So I like to say that it's very interesting to have an SME perspective and then go work for the government back in Washington, D.C. It's good to be here. And now leading a nonprofit institute whose basic whole purpose is to help and increase the manufacturing ecosystem. It's why we are in existence. So it's pretty exciting for me. I've only been, let's say, 2 months on the job. So I am the new executive director of the Digital Manufacturing and Design Innovation Institute. So, if there's any hard questions, I'm going to send it to the other members on the panel up here. I do want to say that what's incredible about DMDII and why I'm so excited to be there is it really is all about partnership. So it's great, like even up on this table right here, as you saw from Sean, he had the great picture. We are so excited to have Autodesk building out, literally breaking technology on the shop floor. We've done projects with Rockwell Automation. So we have a lot of big companies that are members like Boeing and Lockheed and Dow, but in reality, a huge portion of what we are doing and what we are all about is helping the SME community. So I'm going to give you a couple examples, and I'm going to tell you a little bit more. I know that we talked about it briefly earlier, but I do think it's important to talk about, because we're talking about ecosystems, about the Manufacturing USA Institutes. You probably saw them. There are 14 of them around the United States. We are one. Our vision is every part better than the last, and what we are concerned with is the digital revolution. So we've heard a lot about all the different factors, which I'm glad my colleagues have gone through, from artificial intelligence to blockchain. All these are critical to the United States' competitive future. So basically, we were launched literally almost 5 years ago, so in 2014, and I would really like to thank the vision, particularly of the Department of Defense. U.S. Department of Defense is our primary funder. It is the funder of 8 of the 14 institutes. So they have realized way in advance the critical nature of the supply chain for the United States and how it is all about our future competitiveness. But besides the U.S. government, which has been an incredible partner, obviously we have a membership organization which includes over 360 partners. So while there's big companies, again, the vast majority of that is made up of the SME community, as well as our partners in universities and academia. So that's kind of what's the great thing about this nonprofit, is you're combining government, industry, and academia all together in one place, really, to move us forward into the future. So let's get a little bit more specific. That's kind of some big overarching where we're at in the ecosystem. Here's kind of what we've been talking about, and really has been talked about by my other panelists, is every part better than the last. What does that mean? You can see it's really, in our opinion, made up of four areas. I think there's a pointer on here. From moving manufacturing to the left, and Sean did an incredible job talking all about that, to the future factory. And we have basically a 100,000 square foot facility. We have a future factory, which I'll show you a couple examples of what we do on that factory. Again, it's open to the public. We invite you to come, take a look. From Future Factory, we go to the supply chain, and obviously Dave talked a lot about the digital twin, what we're doing, digital thread, digital twin. We think it's critical to the future. And finally, last but not least, because sometimes I think it doesn't get enough attention, and particularly in the SME market, is the importance of cybersecurity. As the sensors get cheaper, as we gather more and more data, obviously it's equally critical to protect that data. And a lot of people, again, we know this in this group, that manufacturers are actually the #1 target. So that's who's being targeted internationally for our intellectual data, our proprietary data. So cybersecurity and how you're going to be protecting all this incredible new digital information is a really important piece. Here's, these are going to be some photographs of our shop floor, our future factory. For me, it's always still a shop. But again, talking about workforce and exactly what Dave said, like come out, come see it, bring people in. I know Stephen visited earlier this year, and since you can't all be there, we're going to bring some of the pictures of it to you. This example is of a discrete manufacturing test bed. You can see right there is a little token. We kind of call them challenge coins, tokens, that we're producing on our shop floor. And really, why are we producing it? It's all about showing an actual example. Sometimes digital is hard to see, it's hard to define. You know, what we're doing is exactly what these guys have talked about. We measure temperature, we measure humidity, we measure everything related to this part, capture it in the digital cloud, and we'll be showing various, you can see up here, some of the screens, like again, trying to make digital real so you can see what's actually happening on the shop floor as we produce these various parts. Here is a second example, and this is our assembly test bed. This is really fun. Basically, this was a Stanley Black & Decker line. We took everything that they were doing in their shop as they assembled a part manually, and we digitized it. So what does that mean? There is no paper. Sean, you'll like this. No paper anywhere. If you see, there's projectors and screens projecting down here. These are various stops on the way to producing the part. So there isn't anything done. Your hands, if you make a mistake, it's videoing you. It will tell you, move to the left, go to the right, all on there. You actually put your own code in so they know what the person is doing. Each person is tied to each area, so you can tell how much faster, how much more efficient is one person versus another. Are they doing something better? It's one of those great things that I love about workforce training and development. It's how do we make already incredibly trained people better? How do we make them more efficient, using digital manufacturing processes?
And even I was able to successfully make the part. So
really?
That was
You
impressive.
were, Stephen?
Yeah, that was
Oh,
shocking.
see, that tells you can take an average, above average person and create an incredible part. Like, that's I could do it too, so I'm not sure what that means, but it's great that we can do that. So it's just this is just an example. So what I'm showing here is examples of what we're doing in various ways. All these spaces you can see are reconfigurable. We can do new and different things, but I think it's really great to visually show people this. And what I think is also really great about this, we talked about Stanley Black & Decker, but the reality is Light Guide Systems, Tulip, even startups and stuff are helping us and do this. So they are an important part of this project and this ecosystem. So I just wanted to call that out as well, that it is also about, and Stanley Black & Decker wanted that. Like, again, these large companies, they want the SMEs to be their partners in these projects. They want them to help create and help move technology forward. So I really want to give a shout out to the startups as well, because they're a critical part of this ecosystem and cutting edge technology. Okay. This isn't as quite a pretty picture of two people. What I have this is something that we are going to be doing in 2019. So I don't have actual pictures of it yet, but we're pretty excited about it because it goes right to the heart of this discussion. And that is doing digital evaluations. So all this talk about digital, how great is that? And then we talk about the SMEs. 70% have had no even vision of the future on how they're going to implement IoT or anything digital. So in order to move forward, you have to know where you're at. You have to know what the potential is. You have to know where you're going. So what we are doing in partnership with Deere is that we're doing a digital evaluation program. And in 2019, we're going to be going to, I think, 6 of their factories doing an assessment. They're digital. Where are they? Where are you at in the chain? And then we're going to benchmark that data, and we're going to take it out and be able to do these assessments to SMEs and larger companies across the United States. So we're pretty excited about this, and a big shout out. I know we've heard a lot about the importance of the Manufacturing Extension Partnership, MEPs, but they are a great partner in this. And how do we get out into the communities all around the United States to be able to talk to them about where are they at on the digital roadmap? I mean, many of them don't even have a digital roadmap, as we said. So, this is kind of a step one. So that will be 2019, and look forward to that because, again, we will hope to roll it out across the United States, manufacturers all over, particularly the SME community. I will also add right here, we, as was mentioned before, we do have the National Center for Cybersecurity. So another area that we were looking at, which again I think is a particular interest to the SME community, is also doing cybersecurity assessments. So again, you have to know where you're at in order to improve and to move forward. And one of the things we realize is that particularly in the SME community, there's just not enough knowledge base even of what's needed and what the potential threats are. So this isn't even solving the problem yet. What we're starting with is identifying the problem, like letting people know where your areas of risk are and what you need to do going forward. So we talked a lot about jobs and what the importance of that to the manufacturing community. In fact, Dave was just talking about it at the end of his speech. This is a really great tool. This is our digital manufacturing and design job roles taxonomy. This is on our website. It's publicly available, so we encourage you to go and download it. Again, we're talking about the digital future, but we have to define the jobs, the skill sets, the responsibilities that are needed for the future. And in fact, I laugh because this was just done a couple years ago, and already I would say some of the jobs are out of date and not correct. Like, that is how fast this is moving. So one of the, again, I like to be really practical, right? One of the practical uses of this, and Dow, for example, was one of the companies that have used this, as well as some of the SMEs, in terms of creating job descriptions at your company. How do you even create the job descriptions for the digital and the technological needs in the future? So this is a taxonomy. It basically, I think it's roughly 165 jobs are defined in this, and then several of them we go into a deep dive where it talks everything about what the requirements are, what the needs are, how do you move forward, how do you promote people like within these various job threads, job digital threads. So we think this is a really important, and we're going to be updating this again 2019 taxonomy 2.0 moving forward on that. Okay, see, I was the good catch-up hitter, but I will end with we are incredibly excited. Again, as Dave said, the future is brilliant. I mean, what we have in terms of assets in the United States, we have a lot to talk about international and great investments that are being done. But the reality is we are still the most innovative and entrepreneur community in the world. And I think with targeted, so I would agree with Dave, continued targeted and continued investment in this manufacturing space. And again, I'm really proud of all 14 institutes. So I would encourage people that are listening to come be members. All these are their own ecosystem. We each have a different topic. If you're interested in digital, come to DMDII. If you're interested in lightweight materials, go to LIFT. The reality is these are ecosystems already. So we know how hard it is, to get the data and the information, the latest and greatest that you need. One of the great ways to do it is to leverage, these institutes, leverage your government and academia partners, leverage the larger companies that are members with us. And so I just want to say with that, thank you, and really looking forward to the next panel as we talk about policy. Thank you.
Thanks, Chandra. DMDI is really playing a pivotal role in driving the digital manufacturing ecosystem forward in the United States, so thanks. Wanted to open the floor very briefly. If we might have a question or two for this audience, why don't we take any questions at once, and we'll move on to the next panel. Just say your name and who you're with, please.
Hi, I'm David Crane with Autodesk. Thanks to the panel. Chandra, I just wanted to follow up on your job taxonomy effort. Is that sort of just defining what sort of job categories are, or are you also looking at what the job needs, demands are going to be in particular industries, going forward? Which seems to me to be something that would be ongoing. You'd have to constantly be updating.
Yeah, as I said, we're already out of date. And maybe we'll be out of date the day we publish, to be honest. But no, actually, yes, it is, to answer your question, it goes more. It's not just a description, right? So it does talk about all the processes, all the requirements that are needed. So, for example, one of the jobs may have 20 pages attached to it of, here, and also promotion opportunities and what's the next step from this job into the next job from the digital innovation. I do think, though, there's much more that needs to be done in this area. So I would call this a starting piece. I don't want to say that, this is the end-all and be-all. I think it's just one step, because the next thing is to start measuring. First, you have to have titles, and first you have to have things that actively capture. Then you can start to measure, where are you going forward and where are the areas of greatest growth, which that we're not doing yet at all. Thank you.
Ladowski from Manufacturers Alliance. I've got a philosophical question. When we talk about SMEs, what is the objective here? Is the objective to allow them to sustain themselves and be competitive? Daria mentioned, I think, quite emphatically that it's access to capital, making sure that they don't disappear, that there is a risk management element to it. Or is it that they be scaled up so that they can take advantage of all of these digital assets that are much more accessible and cheaper per unit when you're much more heftier? What is the challenge in terms of SMEs in this discussion?
So for us, it's connecting the SMEs in and making them a vital part of the ecosystem. So in order to really achieve the manufacturing vision, we need healthy suppliers, small and medium manufacturers. They need to be secure, because you see so many of the breaches that are happening are from the small and medium manufacturers who don't even have a cybersecurity person possibly on staff. So we need them to be a vital part of this and be able to interconnect and to be able to really scale with the manufacturers. That's the goal going forward, to create these big partnerships. And throughout, you see these big, long supply chains that are in manufacturing, and the importance of making those tight and integrated. And that's, from our standpoint, that's one of the biggest elements of this.
I have one comment on that. One of the things that we can do in terms of enabling them at Autodesk, if an entrepreneur or company earns less than $100,000, the software is free to them. Our entire Autodesk collection of software. So that helps them become competitive on the access capability as well.
I'll add to it. I think one of the big issues is awareness. I mean, the bottom line for the SMEs is, they're concerned with cost, they're concerned with competitiveness. Like, staying up on the latest and greatest technology is often not a high priority. You're looking at your bottom line, you're trying to service and provide the parts that the primes or your other folks need. So it's very difficult sometimes for them to stay. How do you stay abreast of the latest? It's hard for even some of us, I would say, to stay abreast. So I think raising the awareness among the SME community and helping them, financially and other ways, like how can they adopt more quickly and more efficiently, for example, digital technologies. Some of them aren't even aware, for example, of what exists. So I would say we start with awareness, and then we build the model to help them move down kind of in this case, I'll say the digital thread or the innovation thread, so they can become more competitive.
Well, fantastic. I think we need to leave it there. I want to thank this tremendous panel for setting the stage and giving us a sense of really how fundamentally transformed the global manufacturing landscape is through digitalization. Thank you guys so much.
All right, if I could ask the next panelist to come on up. And we will adjourn no later than 11:30, and we'll have plenty of time for questions here. So I'm going to call a slight audible and then ask everybody to maybe do 6 minutes opening remarks, and then we'll do a dialogue. Watch out, Paul.
All right.
Hit our robot here. We're going to use the magic of our wonderful beam technology. If you haven't seen the beam technology, it's very, very cool. This is a machine that is controllable remotely. We use it actually on our staff meetings for remote folks, but Sue Helper is going to join us through that. So let me introduce our panelists here. Just going down from my left, we'll start with Tom Justenberg, who is a senior fellow at the Hudson Institute. He was previously director of the Manufacturing Society and the 21st Century Program at the Aspen Institute. And then for over a decade was the president and CEO of the Manufacturers Alliance, MAPI. Has written books in this and articles, and really is one of the leading thought leaders in manufacturing policy in Washington. Paul Hughes is executive director of digital policy at General Electric. Prior to that, he was at 15 years at Adobe Systems and also had a career in the State Department before that. And finally, Sue Helper, who will be joining us in just a minute or so. She may be there. Maybe we can't see her, but maybe she can see us. She is the professor of economics at the Weatherhead School of Management at Case Western Reserve University. She was formerly chief economist in the Department of Commerce and a member of the White House staff during the Obama administration, and did just excellent work on manufacturing policy, but particularly around high-performance manufacturing. And Sue has a PhD from, I believe, Harvard. So with that, Tom. The professor of economics at the Weatherhead School of Management. Wow, that is a really good delay.
Should I go?
Yeah, you go.
Okay. Commerce and a member of the White House staff during the Obama.
Hey, Sue, could you mute your mic? I mean, if you could mute your mic, because we're getting a lot of, the internet tubes are clogged today.
Okay, Rob, thank you very much for your generous introduction, and thanks for organizing this event. I'm going to try to, we've had a lot of good discussion already. I'm humbled to be following some of the speakers that we've had from industry especially. Public policy has a big role to play. I'm going to focus on 3 or 4 things that I think are important. I'm not going to cover the territory. Obviously, there's not enough time. But these are some of the things that I think are the most important things to think about at more of a macro level, perhaps, than we've done so far here today. The first one, I'm going to just leave that. It's all right. First one is the skills gap. I had a conference last week on trade policy when the speaker from NAM, Linda Dempsey, spent almost the whole time talking about what she thought was the most important problem facing manufacturers, including small manufacturers, was the skills gap. We've systematically avoided training the skill force, the workforce that we need in this country. You all know the numbers. They're approximately right. There are 500,000 job openings. The latest Deloitte study estimates 2.4 million in 10 years. I have an article, cut out an article from the Wall Street Journal saying that Foxconn may need to import workers from China to man its electronics facility in Wisconsin. These are scare headlines, I guess, but it's a reflection of where we're at in this country. What I want to emphasize is there are lots of ideas out there. Rob has written a very interesting paper. I think it's a very valuable paper giving very specific ideas. But at the most general level, I think we need to change the culture in this country as we think about the manufacturing sector. You're starting to see this a little bit in conservative political circles. Orrin Cass, who was the research director for the Romney presidential campaign a few years ago and taught at Harvard Business School, has written, I think, an important new book on the importance of work as a life skill and as a way to generate satisfaction in life. It marks a turn away, I think, from the normal conservative unique emphasis on economic efficiency as the goal of all policy. Cass has a number of very specific recommendations. The one I want to focus on, though, is the cultural drive in this country, which has been going for decades, which is that the mark of success in life that we need to impart to our younger generation is getting a 4-year college degree. If you look at success rates of kids entering college, if you look at their success rates after they get out of college, if you look at the debt levels that they've accumulated, it's a real disaster. And that, coupled with the fact that we're not producing the people we need in the industrial sector and in the technology sector, more importantly, I think is a real problem. I think it's going to take generations to change it. What are the solutions? Some of the things, and Rob has talked about some of these. We need a co-equal vocational track between college and skills training in high schools. That existed when I was going to high school more years ago than I care to admit. We need to somehow rebalance the amount of money we're spending on technical colleges versus 4-year colleges. We need to incentivize companies, I think, to take on apprentices. South Carolina, through the German car sector, partly at least, has introduced a system of tax credits. Perhaps we need to supplement the salaries of apprentices. I think Rob has talked about that. Rob has also pushed vocational education in high school, creation of specialized technical colleges, more focused equality between community colleges and four-year colleges. Finally, he's raised the idea, which others have raised too, of a tax credit for firms' investment in knowledge creation and in training. All of these, I think, would be excellent measures to take very seriously. Finally, I'd say I'd like to see the political and cultural leaders of this country get out into the modern factory, go out to these technical centers, learn what Autodesk and Rockwell Automation and others are doing, and start to validate the value of what they're doing and show the young people of this country that there's an interesting career to be had in the manufacturing/technology sector. Second, we've talked a lot about research centers supported in part by NSF and other government agencies. I think we need to take those more seriously. Chandra showed the value, I think, of what her center is doing. I was always a big fan of the supercomputer centers that, at least a while ago, Ohio State and Purdue had, which allowed access to supercomputing power for smaller and medium-sized countries, along with some help in writing the software to solve big engineering problems. But we're just not spending enough money on that. I mean, there was a bulge in the Obama administration when, okay, I've already run out of my time. A bulge in the Obama administration, but the trend is downward now in that we spend too much money. Well, let me retract that. 40, 50 years ago, the bulk of what the federal government spent on basic research was in the physical sciences. Now it's in the biological sciences, the healthcare sciences. Every congressman has a favorite disease that they want to solve. So the result of that is that 55% of all federal money going into basic research from the federal government is going into the life sciences instead of the physical sciences, engineering, and math. Finally, I'll just briefly mention trade policy, which I think is sort of underappreciated as something that can be of help to the small, medium-sized manufacturers. First, do no harm, such as with steel and aluminum quotas, which have been something of a disaster, especially for second, third tier suppliers. We need to enforce intellectual property theft. We also need to work harder to get to achieve progress in protecting data flows. If we're ever going to have a good Internet of Things, we can't have data localization like China is trying to impose on the world. We have problems with Europe with their privacy laws. We need to overcome these problems if we're going to be, especially with small and medium manufacturers, get access to artificial intelligence if the Internet of Things is going to work right. If B2B small businesses are going to find customers around the world, we need a freer flow of data. Some of our trade agreements, like the New Mexico agreement, the TPP, which Trump pulled out of, had a good digital commerce sector and free data flow clause. So sorry to go over time, but
wonderful.
Thanks.
So Rob, I'll give you back the hook card there. Use it on me, and guess I deserve that. So, look, Rob, let me first thank you and ITIF for putting this event on. It's always wonderful to be here. I think this is the smartest crowd in town, as far as I'm concerned, and this is a critically important issue for the United States, as you've heard from the prior speakers. Let me just start, though, by saying I am the third person in my family, to my knowledge, to work at GE. And I just want to highlight someone who came to work at GE in my family 100 years ago this year, Willard Purcell. And this was when GE was only 26 years old, so a little bit more of a startup. He's a remarkable fellow. He was a self-taught man. I don't think he graduated from high school. He built ham radios. He became the first radio operator on a U.S. battleship during World War I. And after World War I was over, he moved to Schenectady and was hired by GE and some of Thomas Edison's sort of first core team. He then went on to be the chief engineer, what was then WGY Radio. Well, this became WRGB Channel 6 in Schenectady. Was the engineer for the first black and white TV broadcast, the first color TV broadcast in the United States. By the way, the first TV broadcast was in something like 1928, and he owned the fourth television set ever. And he is the guy, as far as I know, who's responsible for why GE's Global Research Center is in Niskayuna, New York, because this is a little farm community outside of Schenectady, but apparently it was convenient to where he lived. So, look, it's a real treat to be here. GE is a company that's always had innovation in its DNA. I'm not going to go through our history, but we are focused today on really three areas. One is propulsion of all kinds, engines, whether it's aviation, for ships, related fields like avionics, and electricity generation. And whether it's smart grid or storage, or you want a nuclear power plant or a wind turbine, we're the ones to call. But the third area we're really focused on is advanced technology, which is why this gathering is so important to us. Both additive manufacturing, as you heard very generously from Sean, and I mean, I love that fuel nozzle. By the way, I have a part with an even better statistic. We have a new turboprop engine, the GE Catalyst, and we've been able to use additive to go from 855 individual parts in the engine to 12. But then the other area we're really into is IIoT, and we have a digital division, and I do government affairs for them. Lots of exciting things, but I will spare you the details now. What I did, though, want to do was maybe just hit three very, very quick points in my remaining, I think, probably 3 minutes. One, so what is, GE is a big company. We 120 billion or so in sales, 100,000 plus employees in the U.S. What do SMEs matter to us? And I would say everything, because we have 24,000 suppliers in the United States alone. And you can read all the statistics on our website. You can just Google GE Voices, and we'll tell you on a state and even community basis where we have suppliers. And these are critical partners of ours. The other thing I'll say is we are ourselves a supplier. So while we sell things like finished locomotives, we sell parts to UTC or Boeing or a thousand other companies. So this SME question is critical. We also export $20 billion a year. And so this is the second thing I wanted to hit. What is the business environment like overseas? And we see two phenomena that other speakers have touched on. I think the first is that other countries are all in on promoting their national IIoT strategies and platforms and their related advanced manufacturing strategies. Everyone knows Industry 4.0, but there's Factory of the Future, the high-tech manufacturing catapult, Japan, Australia, India. Everyone has a strategy, and it's promoted at the highest level. When Angela Merkel travels, she will very often sign a cooperation agreement around Industry 4.0 that's coupled with German government grants. It'll be university collaborations on platforms, and this provides an opening for German companies to help provide commercial opportunities. The U.S. government, I want to make clear, is doing tremendous things in this space. I mean, I would commend the White House for what they've done on AI, for what they've done on drones, for the Advanced Manufacturing Strategic Plan. I mean, there is great work being done, and indeed also on the Hill. Thoughtful legislation. I see a number of familiar faces in the audience here from the Hill. But I mean, we believe there's room to really dial it from maybe a 7 up to about 11, both to help the competitiveness of U.S. companies in overseas markets, but also, I think, to really shine a spotlight on the importance of the issue for our domestic SMEs, that they got to get with the program. I mean, we commissioned a survey from a European consultancy called PAC that was looking at, IIoT adoption and predictive maintenance. And in Europe, the survey found that making sure I get the number right, 83% of the respondents on the survey companies had either adopted or were considering adopting predictive maintenance IIoT software. I think the number, as we've heard earlier, is much lower in the United States. The other thing I will mention is the international export financing piece. I mentioned that when GE makes a sale overseas, or Boeing, or thousands of other companies, it's not just us, but it's those 24,000 suppliers in the U.S., many of whom are SMEs that are also making the sale. And we are competing in a global environment against companies that are very sophisticated. I mean, China is probably the best known example. I mean, just open any periodical and read about the kinds of deals they do in Africa, where they come with financing, they come with everything necessary to close the deal. In the U.S., we're, as I think many in this room know, we still don't have a fully functional Ex-Im Bank. We think it's a critical part of promoting President Trump's manufacturing agenda, and we would urge the Congress to confirm the board as soon as possible so we can get the bank fully up and running. There are 60 other countries with export credit agencies, and without the Ex-Im Bank, I really feel all U.S. companies, not just GE, are competing globally with one hand tied behind their back. So thank you. Look forward to the discussion.
Great. Thank you, Paul. I'm always glad to be on a panel or a session where we have a reference to Spinal Tap. Remember that joke? We turn up 11. The amplifier to 11. So, all right, Sue.
Great. Well, I'm really grateful for being here, and or at least remotely, using this great digital technology for this purpose. I guess I want to make 3 quick points and then 3 quick policy implications. So the first one, I think, just to reiterate what's been said, but give some examples maybe, skilled workers are really needed for successful digital adoption. A second point, firms really also need to change their systems to successfully adopt digital strategies. It's reorganizing work, not just taking in individual trained workers. Third, clusters of firms can help, geographically linked clusters. So just to say a bit more about those, I think, sometimes this digital future industry 4.0 is presented as, oh, now I can control my entire supply chain from my iPhone. And so why do you need any thought on the shop floor? I think, the practitioners of this know that's not true. I thanks to Dave Lesko, actually had the chance to tour the Rockwell plant in south of Cleveland, where they have all kinds of sensors, all of their stuff in use in their own plant. And often the sensors, it's not clear what the data is telling you. The data may say that there's a fault, and the fault may have arisen a couple processes before. It's this skilled workers who've been there understand these complicated insertion machines are really valuable in this. Second example is Ford. Ford has these beautiful plants with skylights, wonderful natural lighting, but it changes throughout the day. Automated sensor camera inspection systems don't know that. So sometimes they're going to give you false positives. It's very hard if you're remotely looking at that data, figuring out why is it giving me a false positive? Well, maybe, a cloud came over. If you're on the ground, it's easy. So this is, I think, a basic Toyota principle that we can update, that knowledge on the shop floor is really, really valuable, and it's particularly valuable in interpreting all the data that comes in from these really cool devices. I collected some data on this that just a survey of auto suppliers done this year that if firms actually see IT as a complement rather than a substitute to their workers, that's correlated with a $10,000 per worker increase in value added. So the second thing, but to do this, firms need to change their systems. It's complicated, to present work to a robot. You really need workers to help make those processes really simple, really routine. You need diverse problem-solving groups to take advantage of data and knowledge overlap. This is not an easy kind of thing for small firms to figure out how to do. And so here, clusters of firms can help. My third point, so building communities of practice. So again, in Cleveland, there's a group called Manufacturing Works, used to be called WireNet, offers a user group about how to do the IoT in your factory and plant tours. So it's not just webinars. You could go, you could see how does this work, what are the bugs, etc. Talk to people who are doing it. Small firms get, basically one bet. You can't try multiple expensive things and have them not work because you don't have the money to reinvest if it didn't work. So those are my, analytical points. Policies that I would think about are three. One, on the firm side, consider paying more. Economists think that, skill shortages can often, in fact, almost always be solved by paying more. Leaving positions open until that perfect person that's willing to offer all these skills for very little money, do they show up? That's a false economy. A second issue, I think, of why firms aren't raising wages is this need for systems change. That's very difficult, and so then I think we need some different policies there. One that I would suggest that I was involved with or helped design at when I was in the Obama administration is the Investing in Manufacturing Communities Partnership. You basically use tax dollars to create capabilities. Basically build shared assets, have firms compete on a race to the top of how can they build on their existing capabilities to create a cluster in a particular area. So it could be flooring in Georgia, it could be aerospace. We actually had 4 different non-competing aerospace clusters. This, I think, is a way more productive strategy than our current economic development strategy that involves spending up to $80 billion a year in incentives, tax abatements for individual firms. They basically just determine where the firm locates. It's zero sum from the point of view of the taxpayers nationally. If we can take some of that money, put it into building shared assets that can promote this digital innovation, I think we'll all be more competitive in the long run. We did INCP in the Obama administration. We never had any money for it. We never offered, despite that, it was actually quite productive. People met each other. The economic development people met the workforce development people. It often doesn't happen in communities. If we actually had some money that people develop these plans and here's a few $1 million, $20 million, or something to help you start, that would be great. So I would propose that. I think we need to be thinking really big. When we talk about our competitors, we are dramatically underspending. Just to throw out for a last thought about what the catalyst for that spending ideas around a Green New Deal. I think that manufacturing is a key part of this. We need fleets of clean cars and trucks and rail. We need to retrofit our buildings. We need manufacturing energy in a renewable way. All these things really demand innovation that we're good at. So that would be my conclusion, I guess. Firms think about paying more, fund the investing in manufacturing community partnership, think about building green supply chains. So
Great.
Thanks a lot.
Great. Well, thank you, Sue. So we have a few minutes left. I want to open up to everybody. I just want to make one point, and that is, and Sue, you've done this work, and a few other scholars have done this work, which is counter to the most views of most economists who think that the economy is always in, there's one equilibrium in an economy, and you're always in it, and anything government does gets you out of that. It turns out there are actually two equilibrium potentials in an economy in this space. One is a low skill, low technology, lower wage equilibrium. You can be perfectly productive and perfectly profitable in that equilibrium. And the second is a high wage, high skill, high investment, high R&D, high innovation equilibrium. And you can be perfectly productive and profitable in that. At one level, if you're a firm, you don't care, but collectively we do care. We don't want firms to be in that first category. We want them to be in that second category. And the problem is, as we saw from Dario, in Bologna, they're in that already. So they're already up there, and so sort of moving they don't move down to that. They do things to reinforce that ability because it's a collective action problem. And in the U.S., we're not. I mean, we have a few places that are a little more, and then we've got, these great programs, Sue, the WireNet, which has a new name, but WireNet was a really cool program. But in one way, I think what we need is sort of shock therapy, to really let's get us up to that level so that becomes the new norm. So I don't know if people have any thoughts to that before I open it up.
I'd 100% agree, and really well stated, and thanks for the shout out earlier, Rob.
Great. Okay. So comments or questions, if you just want to raise your hand and then wait for the mic. We have one right up here.
I'm Bob Hershey. I'm a consultant. What is being done to get together funding from various companies and sources to try and look at some of these issues and put together programs? Is anything being done to hold meetings online?
Why don't we take we'll take a couple of questions and then we'll answer them all. So, other questions or comments? Okay, why don't we answer that one, and then I'll ask a couple thoughts. All right, we're building these digital ecosystems. Is there a way to use, sort of virtual collaboration? I know WireNet, for example, they have meetings. Right. You go to a CEO, group and have coffee. Is there a way to do that virtually?
I'll maybe just answer an aspect of the question. I would say, absolutely. I rarely go to a meeting in Washington right now where some aspect of the new economy, digital manufacturing, advanced technologies are not on the table. So I think most companies in DC are seized of this issue, and whether it's discussions with the administration or among companies about the prospect of data privacy legislation of the states, which of course has a huge impact if we get the definitions wrong on industrial Internet of Things and industrial data, as we heard from the speakers earlier, or a discussion on Exim Bank that I mentioned, or there's a new coalition that's formed around additive manufacturing. I think it's called the America Makes Coalition, which GE's vice chair, I think HP is the chair. So there's a huge amount of industry and government attention on the issue. I guess maybe what we lack is, I talked about turning the volume up to 11, but maybe we lack an easily sort of understood organizing principle, sort of like Industry 4.0, which is a great tagline. Although I would note that it is really very, very focused only on manufacturing and kind of misses out on a lot of other areas where U.S. firms are competitive. So I wouldn't suggest we just adopt Industry 4.0.
Call it 11.0.
Exactly.
So I want to come to Tom and ask a question. If you haven't all seen the report yesterday from the Trump administration, I would encourage you to look at it. It's, I believe, an OSTP report on a very good, a comprehensive plan, agenda for what the administration wants to do with regard to STEM education, including some of these technical educations. Tom, we've been talking about manufacturing skills for 30 years. And, we do a little bit. It doesn't seem to ever sort of get to that point. And I don't know, maybe we're at a turning point where people are realizing getting a 4-year degree, and I will already offend several people here, in something like French literature maybe is not the path to success in life. Sort of that seems like that people are becoming more aware of that, but where do you think we are, and how do we get over the line on that?
Well, I mean, it's been longer than that. I think that we've had sort of waves of renewed interest in things like apprenticeship systems. The Clinton administration made a jab at that. Yep. Then it got lost. I mean, that's why I try to emphasize this concept of a cultural change. You know, we look out at the audience and you can see survey data. Middle-class parents don't want their kids to go into, you know, technical jobs. At the higher levels, if you will, of, you know, research, information technology, we're doing a better job. Part of that is due to the influx of foreign students into the United States. But at the, you know, research level, we're doing a terrible job, and it's, in my view, at least in large part, because of the cultural bias against working in a factory. There are too many memories of you know, dirty factories and health problems and the like. And there's not enough awareness of what the modern factory is like, and there's not enough awareness of the what, you know, Oren Cass and a bunch of others talk about in terms of job satisfaction, which is a weak way to express this. It's satisfaction in life, satisfaction in actually creating something, building something with your hands, or contributing to something. And it's going to take a long while to get back to a point where there's recognition of that, if we ever do. That's why I think it's not only you know, political leaders who need to get out there and visit factories and, you know, create stories about it, but why not our cultural icons as well? One of my favorite Super Bowl commercials of all time was a few years ago. Bob Dylan did something for Chrysler, which I thought was perfect. You know, I don't know if any of you remember that. I'd like to see more of that.
So, let me just quick aside. You know,
I would
go ahead, Sue.
On that, as an economist, I think that you need to also look at wages, and I think, you know, go back to Rob's point. I think the people here, you know, are thinking about implementing a high road manufacturing system, but that's not the only way that manufacturing is growing in the U.S. That there's a growth in the low road. There's increasing use of temporary workers who are very ill paid. A quarter of manufacturing production workers have access to social safety net. They're on food stamps. They're on Medicaid. These are not good jobs. So I think we have to actually, if we want to have an image of manufacturing as good jobs, we need to actually move to create the reality of good jobs. And just to add on Rob's point, I think that when there's a low-road manufacturing firm, it actually hurts supply chains as a whole. And it's hard to do value analysis, value engineering to improve product if you don't have a capable supplier. I did a survey in 2011, and 20% of small auto suppliers don't have any engineers. Many firms don't do preventive maintenance, let alone predictive maintenance. This, you know, hurts the reliability of the whole supply chain. And so I think about, you know, moving this, I think, really great vision of manufacturing as a really clean place to work, where there's a lot of use of information and working smarter rather than harder. I think it's a really great vision, but I also think a lot of work needs to be done to make that a reality. And so people are not wrong always when they have an image of manufacturing as dirty and dumb, and let's change that reality as well as the image.
Yeah, and I think the challenge here is that it's a collective action problem or a cumulative causation problem. Because there are manufacturers out there, it leads to that image, and you're a worker or a student who want to get in that, and you see that, and you go, I'm not going to do that, and then the companies like we're talking about here, don't have the skills they need, so they can't upgrade, and it all feeds on itself, and that's why in sort of we need maybe a big bang approach of let's really focus on it for 5 or 10 years and make the transformation. But Tom, you were going to say something.
Well, two quick things. Wages at the lowest levels finally are starting to increase in the last 3 years. We are not at full employment, but we're getting there, and there are some increases. But to think big, and I just throw this out on the table because this guy, Oren Cass, has proposed this.
By the way, Oren, we did a book event with Oren about 3 weeks ago, so if you want to watch the video, it's a good book and a compelling talk that Oren gave.
Well, he threw out the idea, seriously, of rethinking the massive income redistribution programs that we have, welfare programs, if you want to use the pejorative terms. I don't know what we spend, $1 trillion a year. He'd like to see some of that money converted to a wage subsidy to raise the wages of low-income workers. I haven't read the full book. I've read a summary of it. But he's got a somewhat well-articulated idea for how to do that. Welfare reform, whatever, is the third rail of American politics. But maybe it's time to think about trying to convert, and he uses the example of some Scandinavian experiments in this over the last 10 or 20 years, where you give more of an incentive to work rather than to support non-work. So,
go ahead.
Sorry,
well, then we have one more question.
To add a grace note on your question, I think the sine qua non for making manufacturing an attractive career for people is really the availability of the jobs. And to return to the Ex-Im Bank, I think a fully functioning Ex-Im Bank with a full board is critical for American manufacturing and exports. I mean, really, without that, we need to be sure the jobs are here, then make sure they're attractive.
Right, so there's this view that manufacturing jobs have gone away, which part of it is true to trade, and there's a view that this jobs don't pay enough, partly true, as Sue has pointed out. So if we can't get manufacturing jobs back, we can't raise wages, people aren't going to want to do it, but we can't do that unless people and companies do the right thing. So again, it's not this sort of equilibrium. It's something that you could easily see it just continuing to go the wrong way, or we could shift it the right way. Last comment, and then I apologize, we've gone over a few minutes, but right here, Chuck.
Well, very much in support of what you're saying, but there are models. I'd be interested in Paul's view. New York has stepped up and to some extent solved the collective action problem. They have the Hudson Valley Community College has an outstanding program. There are impediments. The State University of New York takes 2 to 3 years to change a course, which is roughly 3 times the time needed to actually serve industry. And those problems need fixed. But I think if you use either at the state level or at the federal level, one of the geniuses of the Manufacturing USA is the matching. Mm-hmm. It's the federal investment is much more catalytic. And Paul, it's also I think Sue has some important points that paying the IBM contributions to the College of Nanoscale Science and Engineering are all models that can be used throughout, but the corporations also have to step up.
I'm going to take that as a comment, Chuck, and exercise moderator prerogative here to end the program. As much as I would love to continue the conversation, I think if speakers will be here around the room if you want to chat after the event. But please join me in thanking just a wonderful suite of speakers this morning. And I'll leave on an optimistic note. I know there's certainly interest in both chambers and both houses. The Trump administration is taking serious efforts on this. So I'm hopeful that we'll make some real progress, at least in the next Congress, and move forward. But I want to close by thanking you all for joining us today, and appreciate you coming by.